Hi students, welcome to physics class. Today we will discuss about some problems on maximum height and range. In this problem we have to prove that the maximum height is 1 by 4th of its range at the angle theta is equal to 45 degrees. We have to prove maximum height is equal to 1 by 4th of its range at theta is equal to 45 degrees. We know that maximum height h is equal to u square sin square theta divided by 2g. By substituting theta value we get u square sin square 45 degrees divided by 2g. Here sin 45 value, the value of sin 45 is 1 by 2, square root of 1 by 2 or 1 by square root of 2. By substituting this value we get u square sin 45 degrees is 1 by root 2. Here we have sin square, so we get 1 by root 2 whole square divided by 2g, whose value is equal to u square. This value becomes 1 by 2 and finally we get u square by 4g. This is the maximum height. Next one, we know that range r is equal to u square sin 2 theta divided by g. By substituting theta value we get u square sin 2 into 45 degrees divided by g. We know that sin 2 into 45 becomes sin 90. Sin 90, we have already u square here, u square into sin 90 divided by g. Sin 90 value is 1, so we get u square divided by g. From this expression, maximum height expression, u square by g is equal to r. We have already derived range. So from this expression, let us say expression 1 and expression 2, from 1 and 2, we know that u square by g is equal to r, so we get h is equal to r by 4. Hence we have proved that the maximum height is equal to 1/4 of its range at theta is equal to 45 degrees. We have taken this angle of 45, angle of projection we have taken here. Theta is equal to theta is equal to 45 degrees. Here this value is 45 degrees, and we have proved that height is equal to maximum height is equal to 1 by 4th of its range. Next we have to note some important points here called as complementary angles. Complementary angles. Let us suppose angle of projection 15 degrees and 75 degrees, 20 degrees, 70 degrees, 30 degrees and 60 degrees, 40 degrees and 50 degrees. All these angles are called as complementary angles because each pair add up to 90 degrees. 15 plus 75 90, 20 plus 70 90, 30 plus 60 90, 40 plus 50 90. So these angles are called as complementary angles. In general, these angles can be represented as theta comma 90 degrees minus theta. These angles are called as complementary angles. Here in the figure, we can clearly observe that at angle of projection 75 and at angle of projection 15 degrees, the range obtained by these two projectiles is same, whereas the height reached by the maximum height reached by the projectiles, the maximum height reached by the projectiles will change. So for, let us say, theta is equal to 30 degrees and theta 1 is equal to 30 degrees and theta 2 is equal to 60 degrees, h is equal to u square sine square 30 divided by g 2g, whose value is equal to u square into 1 by 2 whole square, because sine 30 is 1 by 2 divided by 2g, which is equal to u square into 1 by 4. By simplifying we get u square by 4g. In the same way, let us say h1, this is h2, u square sine square 60 degrees divided by 2g, which is equal to u square sine 60 is root 3 by 2 whole square divided by 2g, whose value by simplifying we get u square divided by 3u square divided by 4g. So for the complementary angles, the heights obtained by the projectiles making an angle of projection theta 1 and theta 2, we get different angles of, for different angles of projection we get different maximum heights. For minimum angle we get the maximum height value minimum, and maximum angle of projection we get maximum height, highest height compared to these two heights. In the same way, we can calculate the range R1 is equal to u square sine 2 into 30 degrees divided by g, whose value is sine 60. Sine 60 is root 3 by 2. We get u square root 3 by 2g, and range R2 for the angle of projection theta is equal to 60 degrees is u square sine 2 into 60 degrees divided by g. Here sine 2 into 60 degrees becomes 120 degrees. 120 degrees can be written as 180 minus 60. Sine of 180 minus 60 is equal to sine 60. So u square sine 60 divided by g, whose value is similar to this one, that is u square root 3 by 2g. So for the complementary angles we get same range. The range obtained by the projectiles projected with the complementary angles is same. Here we can clearly observe for 30 degrees and 60 degrees the ranges are same. We obtain the range from point of projection to point of landing is same for both angle of projections, but maximum heights will differ. The maximum height will differ. The maximum height is maximum for the maximum angle of projection among the complementary angles, and for minimum angle of projection in complementary angles the maximum height is minimum. That is about maximum height and range problems. Thank you.